Today I'm actually in Shreveport, Louisiana at a technical college. I'm hoping that my connection will stay strong and we will have no connection issues. So we appreciate everybody's time. I do just have a few slides that do not make J's, but if you're looking for more information, a lot of the stuff that people ask about is on retrotec.com. The staff and colleagues are diligent about anything that we come up with new information is always being added to manuals. They constantly have it constantly updated. So under support, they have a section of manuals and guides or the webinars. All those things can be found there. I cannot stress enough how great feedback we've been getting on the road about QuickGuides and manuals, especially the QuickGuide people like, wow, I had never used one of your types of systems, and they said they can open the QuickGuide and actually go through it pretty fast. So if you're not familiar with the website, I highly encourage you to go through there and check that out. Oh, I was going to skip some of these slides. I apologize. So one of the things that I want to make sure I'm not covering is how to evaluate opinion neutral typewriter, how to evaluate your ventilation requirements and if you have enough infiltration, exfiltration, if your fans are all. So we always send people to those kind of questions to Residential Energy Dynamics. They have this awesome software, and it's right on their website. It's easy to use. If you hover over any of the fields, it actually has a little help to tell you what it is and why it is. And so RED is usually how we refer to them, Residential Energy Dynamics. It can help you with any of your ventilation questions you might have. So one of the things I want to talk about today is testing exhaust fans versus a supply, and what are the differences in some of the different test methods that are out there and why some are actually a little more challenging than others. So exhaust fan flow is trying to pull air from the inside to the outside, and we have a variety of devices that can measure that. Air moves through the device, gives us a reading, and we determine how accurate we are. The more challenging is when there's actually air moving the other way. So the supply register is the obvious example, and we have a device. Typically, it's not always the same device. This actually device is much more challenging to use. So it has to be able to handle airflow into the device and not actually be disrupted or get false readings by air flowing into it. So there's a variety of different options to do that. So most things are passive devices that we use. We're going to go through a few of them today. And so as the air moves passively through the device, it's able to understand the pressures based on a known opening in the device and say, okay, here's your answers. The other option is if you actually have some kind of power system where it actually has a fan in the middle that's able to match the air that moves through. So if I know that on the top here I have so much air moving out of it and moves through it, the fan can then be turned on and actually match the same pressure, so it's more of a pressure matching kind of a measurement, and then I actually have an accurate measurement. And where that becomes much more sophisticated is when you actually have air flowing into it, that would actually be a much better measurement. One of the things we will focus on is the Energy Conservatory Exhaust Fan Flow meter, the black box, as some people will refer to it. It is a really pretty intelligent, simple device that allows us to measure the majority of exhaust fans and many kitchen type of exhaust fans also. We'll go through how to set up use the DM32. I do touch base on the DG700, but it's mostly people get challenged on how to use the Retrotec gauge with those. We'll also talk about how to use a DucTester as a flow device. There's also a Retrotec flow hood, which allows you to also use that in combination with a DucTester. And Retrotec has the gold standard of measurement of flows, whether it's passive or supply type of a device. It is the FlowFinder. It is a powered flow hood, and it's capable of registering incredibly low numbers, and goes up to around, I've measured 400 on its normal rate, and it can go up to 500-600 CFM on an interpolated scale that it has. So many of the industry gurus out there and people that are actually determining a variety of stuff, Berkeley Labs and a variety of other high-end folks who test stuff, have bought several of these to use them as their standard. I actually do not have the flow blaster. I've been trying to acquire one. I've not got one yet. and I'm not going to talk about the Allen flow hood. So these are things that are not in our discussion today. The Energy Conservatory is a powered flow hood. The Allen is a passive flow hood because it does not actually match the air that moves through it. We will briefly mention the cardboard box, but I'm not going to go into the details about it. But you can actually build your own exhaust flow meter device. Right? This can measure exhaust fans. This can measure kitchen exhaust fans. And where this is actually incredibly valuable is if you have the really large kind of commercial type kitchen exhaust fans, the ones that are 600, 800, 1200 or more CFM that they're putting over their in their kitchen. If you're not careful, you can lose your gauge, or small children should not be near those types of fans. So what you're trying to do here is use the gauge, the DM32 gauge, has the ability to measure the amount of flow that moves through a known opening. So you can download their the DucTester guide, and several of the pressure guides have this exact description. The illustration I have, I wish the hole was a little smaller when I did my measurements, so something around 3x3, 3x6 does a good job. And we'll talk about how the tubing gets connected in order to read your measurements. But right here I'm trying to measure on the blue tube on channel A the pressure, and channel B on the yellow is reading the actual flow that moves through the box. So it's a very accurate system that you can use. You just want to make sure that your pressure tube is not in the flow directly. It's off to the side, and it's as accurate as any other device that I've kind of used for challenge purposes. We do not talk about the garbage bag, but you can download these types of options also. These are used to be at one point standard of how to do some of this. They're still accepted in the actual Canadian process of evaluating homes. It's still in their standards, and there's a variety of ways that you can actually use a garbage bag if you know the volume of how much air it holds. So it depends on what we're going to talk about when you're testing. So the most common one is exhaust fans in a bathroom, and the requirement is that it must be not the labeled amount that the air moves, but actually really what it actually does when it's installed, if you really want to test it for compliance and accuracy. So the minimum is 50 for an exhaust fan and 100 CFM for a kitchen. So we're going to talk about how to test some of those types of devices. So here you can see the exhaust fan flow meter on the right and the FlowFinder on the left, and they're both fairly giving you fairly similar numbers. Only the exhaust fan flow meter does a passive type of reading. So here it is kind of in action. All right, I'm going to step through how you actually go through the gauge and the setup. All right, I have on the right I have an exhaust fan that's just upside down, so I can use it for demonstration. And on the left, I'm showing you where I'll be at the end, which is how to use two connections, so that you can always read the pressure that is going into the device itself. And on channel B, it gives you the actual results, how many CFM is actually moving through the exhaust fan as you're measuring it. I'm going to kind of step through the gauge, because this is the really common question that I get is, I can't get the exhaust fan flow meter to work with the Retrotec gauge. Right? So my goal was frantically threw together a couple slides here and can step you through what to do. So the first thing you want to do is the exhaust fan flow meter is a device just like a DucTester or a blower door. And so you're gonna, if you want, you're gonna change the device by actually tapping on the image of the fan, and this automatically takes you to whatever device you're using for its ranges. At the bottom, you can do change device, and that'll take you to various screens. In the bottom right corner are the little dots or the different pages. So on the Energy Conservatory devices, you can actually operate the duct blaster, their blower door, 110, 230, or the TrueFlow grid. But today we're going to focus on the exhaust fan flow meter. So you actually just tap on it, and it automatically will take you to the ranges or the options for the device. So you can think of these as rings, as you do your blower door or your DucTester, and it actually is a restrictor that allows the calculation to be effective. So in order for you to measure the amount of flow, the amount of CFM, you must know the pressure and you must know the size. So if you know those two, you can actually determine your conclusion. So on the bottom here, so I now have selected the exhaust fan flow meter, and it's on the range E2. I think the image may have E1. That's E3, so the image doesn't actually match, but I wanted to go through the exercise. So again, so the Retrotec gauge, the left side of the image is channel A. That's the blue and the red, all right? So that's the input and reference. Channel B is the reference and input. So you're reading. So the top line where I have 0, 0, that's related to the blue and the red connections, and the yellow and the green are part of channel B where you get your results from. Most of the devices that Energy Conservatory has, their blower door, their duct blaster, and their exhaust fan flow meter, they actually connect to the input on channel B. So if you follow the instructions that are provided with the devices, it says, oh, connected to the input. And if you did that for the Retrotec gauges, you do not get a reading. The Retrotec gauges actually take their reading for the device off of the reference input. So if you're a trainer, or if you have both gauges, or if you're trying to figure out how to make this work, the key for Retrotec gauges is that they always read the device from the yellow port. One way to remember that is that all of the fans of Retrotec cells are yellow. The DucTester and their blower door fans are yellow. Their color system is yellow to the yellow fan. Okay, so I have my exhaust fan flow meter selected. I've connected it to the actual device. And right now, the only place where I'm going to get a reading or have anything show up is on channel B, because it's the only place where I have a tube. So only channel B is going to provide the results that I have here. So there's stuff. Okay, so screen jumped around, but it works. So right now, I actually have a result of 52 CFM. So I can say, okay, this fan is moving what it should be. And the reality is that you want to make sure that you're above 2 and below 8 pascals. So what I did now is what I have is both. I'm going to go back to make sure you see the difference. So here I have just the yellow tube on channel B on the reference, and it gives me 52 CFM. If I want to read the pressure at the same time to know that, oh, I still am in compliance, there's no challenges here, is that I can then go forward and add a blue tube, which doesn't really line up very well, to the input, and now I can actually see on channel A the actual pressure. If I were to set channel B to read pressure, these would be reading the identical pressure. Channel B is just now converting 6.2 pascals with this device into 52 CFM. So this is the one challenge that I really highly recommend that people are doing. Many other trainers that we work with and teach this feel that no matter what gauge you're using, you really should always be trying to reference both sides so you know what your pressures are and you're in check. Many of the numbers that you're seeing here could also be converted here on the side. So I could say, oh, 6.2 with the E2 range configuration will give me these results. We use the gauge to do it automatically. Yes, okay.
So Joe, if there's only one tap though on the exhaust flow hood, so how do you get 2 tubes into the one tap?
That's an excellent question. So I will probably, what I do just for a second, I'm going to, let's hear it, great, let's hear it. I'll go back to it. So when you get your Retrotec system, it comes with a little accessory kit. It comes with a pressure probe and a variety of other key things, but it also comes with several T's. So if you can see in the image here, on the right side, I actually have the Retrotec DM32, and I have the blue and the yellow. I try and always keep the color coding correct just so it makes sense to a viewer. And you can see that I have them teed together, and then I use a clear tube just to keep the rest of it neutral. On the left side, I have a DG700, and you can see that channel A and channel B are both on the input. I use the same colors to kind of keep track of the tubing, and then there's a clear tubing that goes into the device itself. So it's basically, it's a little plastic tee. If you don't have one, I know that Lowe's and Home Depot sell these over in the plumbing section as a part you can actually add to your system. And so here I did the same test with both of them, and they were both almost identical results. But I can also see the actual pressure that goes along with that. All right, so the other option, are there any questions about the exhaust fan flow meter? So I'm trying to make sure that people understood where to make those connections and how to go through that. So if you do have any questions, I've got my questions section open here. So if you have anything, I'd gladly will make sure we address that. If it comes to you later, don't hesitate to throw that out. So the exhaust fan, my keyboard is very sensitive. So the other one is to use a device that actually can handle either flow. So this one here I showed you just to compare what the numbers were. This is the FlowFinder, and here it's upside down in terms of how I use it as the demonstration. But this is as simple as actually covering the fan and hitting one red button for a brief second, and it does it automatically. The fan itself will match pressures and determine your CFM. And it can do numbers that are incredibly low, or again, it can definitely handle most of the needs we have. It does not do commercial applications at this moment. The other one is, and I'll show you how to use your DucTester as a powered flow hood by itself. But one of the things you can also use is that Retrotec sells their powered flow hood adapter, and it's basically like a large pressure pan with an opening on the top that you can actually put your flange here in the section and connect it to your DucTester. So it will allow you to cover larger exhaust fans or a variety of systems, including a return up on the ceiling. And it comes with 2 pole connections if I want to do something on the ceiling and keep it up there permanently. And it has a variety of pressure taps on the inside for better reading on throughout the system, and it's got one pressure tap over here on the top. So here it is by itself, so you can see how it works with the system itself in relationship with the DucTester. And you can, if you're interested in those, Retrotec sells those directly. They may be available with some of the other distributors. So when you have zero pressure in your device that has a fan, then you have achieved a measurement. So here I'm going to take my DucTester, and what I'm going to show you is how to, you could use it on an exhaust fan. You could also use this on a supply if you wanted to use it for how to measure air coming out of a register also. So this could work on an exhaust fan, or a variety of things. So what I'm trying to do is just match the pressure inside my flex duct, basically, in a neutral area that's going through. So my exhaust fan, then I can actually take the red flange, or the flange you use for the DucTester. I'm going to make that connection, and I'm going to get the blue tube to be reading the pressure that's in this area. And it just cannot be in the direct flow. It has to be some type of passive pressure device, or even just kind of covered so it reads pressure without actually having airflow into it. And then I connect my gauge to the fan itself. Usually for this, I don't use the speed control. I use the speed control knob on the fan itself to match these pressures, because usually they're very subtle or very slow in order to increase that. So I don't really try to do set pressure on the gauge. I've learned that it's much more accurate, better control by just using the fan itself. So many people are used to Retrotec as you just hit set pressure and you control the fan with the gauge. But there is actually a speed control knob that's right here on the side of all the fans, so I actually have a speed control at any point I can use that. You need to make sure that your Ethernet connection is not connected to the gauge and the fan in order to do that. Once I have the fan moving, so let's see my next slide to do for me. So I'm going to adjust the fan until I have zero pressure moving through. So if I go back, you can see that when I first had it, I had a negative pressure showing up. And now what I'm going to do is I'm going to turn the DucTester on slowly until that reads zero pressure. And then I'm going to get a reading down here below. right? And that reading is based upon the range. You see if I have the DucTester as my device with the mid-range, and that's what the device would look like. And it's able to read the amount of flow that's moving through it. And when the flow is 0, that means I now know that I'm not having more or less flow going through, then I'm reading the same CFM that must be going through the exhaust fan. A couple questions here. I'll see if I can grab these real quick. John is asking, what would the tap look like inside of the flange or inside the duct? One of the methods that I use, I don't have a picture of it, maybe it's very clear, I may have one coming up, is I use Velcro, and I use some kind of sticky Velcro in it, and then I actually put the tube in, and then I put the other part of the Velcro on it. So it looks like it's closed off, but the reality is that there's enough pressure that still gets into the tube without it actually receiving direct pressure is one solution that works well there. Having some type of a box that you put below the exhaust fan allows this more stable pressure and allows it to work a lot easier. So connecting this directly to the exhaust fan can work, but I found that if I have a cardboard box, like you saw in some of your images, with the flange, and now I can actually put that tube in it, makes the pressure more off to the side. Your systems come with a static pressure probe from Retrotec. They're easily gotten if you don't have one. And the static pressure probe looks like I have a couple of images coming up, but they're the 90-degree probe, but they only have holes inside. And as long as the holes are not exposed to your direct flow of the air and pointing in either direction, that means air flows over them, then they actually give you a good pressure reading. Someone's asking, since you're just, Scott asked, if you're just measuring pressure, it wouldn't matter if you're using a DucTester with the DM32, it's fine. So I think his question was, can I use the blower door? That it would work, and go ahead, Jack.
Oh, yeah, I think that's, if you want to answer that too, I'm sorry, I was typing a long answer in the background, but yes, Scott's original question was, when using the DucTester, does the flex tub duct need to be fully extended? Would it improve the accuracy? And my response to that was simply that, and if anybody else is interested, but it was the fact that in reality, we're not actually testing the flow through there, we're extrapolating pressure, because remember, these are just manometers that are in the pressure gauge. No matter what gauge you're using, it has a manometer, and manometer just tells you the difference in pressure between 2 points, and it extrapolates flow. So it doesn't make it so that the turbulence and the eddying, the pooling, all the sort of problems that you'll find if you're testing flow through that, like if you were using, say, for instance, a flue gas analysis machine that was actually testing the flow across the hole, that would be different. But then his follow-up question, which I think was really smart too, was that, well, if you're just measuring pressure, does it matter if you're using the duct blaster with the DM32 in duct testing mode or blower testing mode or whatever? So, and my answer to that was yes, it does matter, because in order for the gauge to extrapolate flow from pressure, it needs to calibrate. It's calibrated, and it needs to adjust its calculation based on the fan, the size of the motor, the size of the known hole, all that stuff. So it actually is really, really important, because if the fan thinks it's extrapolating a flow measurement from pressures that would be gathered by, say, a 1000 fan, which is a much bigger device, much bigger holes, then it would miscalculate. So, Joe, anything to add to that? Does that make sense to everybody?
Yeah, just to confirm that, if you're looking for results on channel B, you have to be knowing that the device on the other side of the same area is what you're using. So that's not just crucial that I have the right device, but I also have the right range. So it goes back to using the exhaust fan flow meter, that I had to make sure I had that device and the right opening. They have E1, E2, E3. Each of those gives me different results because they have different openings, just like we have different rings on the other fan. So yeah, in order to get this number, comes from the amount of pressure that's there calculating the known opening of the device it has. So all of these are some significant calculations. If you saw what we did on Tuesday, that there could be 800 some calculations for their calibration just on each range. Moving ahead of time. All right, so one of the things is the static pressure probe. The angle you hold it, the precision is based upon the fact that it's actually moving with the flow, up or down, doesn't matter, as long as it actually matches the flow itself. So you can use the DucTester as a powered flow hood. So here's a great example of a nice box that's over this could be a return. I would actually try to make sure that I would seal at the top a little better, maybe with some weather stripping. I don't know, you may have something I can't see. And you can do these types of measurements with either one of the DM2 or the DM32. So these are a great way of actually understanding the exercise of how how your system works, but also measure stuff that may seem difficult or impossible.
Joe, I want to point this out too. It's probably, I don't know, it's probably pretty obvious, but you'll notice that it's actually hooked up a little bit differently because he's actually running the fan. So it wasn't hooked up, I should say, differently than it was hooked up for just the exhaust fan, just the exhaust hood, the exhaust test hood. Sorry. Does that make sense?
Yes. So I'm going to go back to this same example here that we could actually do that. I know that the air that's being pulled out of the exhaust fan is moving this way, and I need to make sure that the air that's moving through the system is doing the same. So when I turn it on, I'm not battling each other. So in theory, if somebody does, I'll change the slide so that if I change this from an exhaust fan to a supply pressure, then now all the air is moved the other way. I turn the gauge, I turn the fan around. All of the connections with the tubing stay the same. But when I turn the fan around, I know that the fan is actually going to be blowing air the same way. And I can actually measure the supply air that comes out of each one of the registers. So if you really want to convert your DucTester to a powered flow hood, it's really simple. It's actually the best thing to do is to have some kind of box that helps pressure balance with connection to your flange, and you're able to connect your tubing and match the pressure with the speed control on the unit itself. Make sure these two devices in range match, and you can actually measure the CFM that's coming out of your supply registers. So right here, he could be doing that, and we just can't see which way the fan is going. Somebody asked a great question. We did this as a quiz on Tuesday. So the question is from Scott. Excellent question, Scott. Because it wasn't clear on your menu. So if you do have a DM32, we highly recommend that you always check your firmware updates. Right now we're on version 49. If when you first turn on your unit at the bottom, it'll tell you what firmware you're on. If it does not say 49, connect it to your configurator. You can go to the settings and toggle through all the pages, and on the back page it tells you your firmware. One of the last changes in the firmware was that the DucTester appears on the window at the top that says blower door, and it says it shows the image of a DucTester without the actual flex duct on it, and it described it as a 300 to be used as a blower door. And Retrotec has different fan curves if you're going to use your DucTester to do a passive house or use it as a blower door setup. So if you're going to use it for duct testing, if you go to the next page, you see the DucTesters. And it has the 200, the 240, and the 340. So if you have 300 reading, then you actually are reading it as a blower door, and you need to go back and change device and go to the next screen under DucTesters, and you can see 340 will show up, and then it actually is reading and has the correct fan curves for that. So hopefully that answered your question, or other people can pull out their DM32 and follow along with what we're doing. So here's one of the more challenging ones, is how to do a kitchen exhaust fan. So I don't know if Jay has a poll set up, but we didn't discuss it, but I really want to find out is how many of you are testing exhaust fans. So we do not keep track of it, BPI doesn't care or whatever. We're not going to market you on how to buy anything, but I found that less than 10% test exhaust fans. So we want to see, based on our audience, how many people are testing exhaust fans. So without forcing a poll on you, let's get some results.
Joe, we had about 21% that said that they don't test exhaust fans.
Oh, did you? Is that a poll?
Yeah, it was part of the poll. It was what standards they test to, and one of their options was don't test. So about 21% of our audience here.
But even though you have a standard, they may not be testing, but I'll leave that on. So I was sleeping during the beginning of this thing. So so that's good that we actually have, it's all those dumb slides in the beginning, they put me to sleep. All right, so we're going to talk about exhaust fans and the logistics, the challenges, and some of the solutions that are out here. Right? So one of which is it's a clearance issue. So a lot of the other hoods that you may use for other readings do not work. Some of them are split intakes, which make it difficult to read. And I've done some variety of testing with several different kitchen exhaust fans that I have in my houses or different houses, and I have a prop that I also use. So the method on the right, I should change this line and say, is not the way you should do it. Everybody says, oh, I saw this, that's not a good method. And that is correct. Some of the illustrations I tried to do were showing what your results were. So trying to do a method where you close off one side to read the other will not give you accurate results. Your best method is to use something that will encapsulate or cover the entire fan itself, have an area that's open to allow both sides of the fan, whatever way it's set up, to have air to flow through. So whether I'm going to connect my flange for a DucTester, or use the exhaust fan flow meter, or use the FlowFinder, all of them would have an opening that allows air to flow through. So last time I did this, it was like I had like 2 hours, and I ran outside and I made one. So here's what I made quickly. It basically is just some 1-inch foam. It's about 3 inches high. I used some expanding foam and tape to kind of seal it off and glue it together. And I cut a hole in the beginning and inside. I changed the round hole to a square hole so that I could then use it as a passive device. So once I made it square, then I could say, oh, this is actually 3 inches by 6 inches, and use one of the methods that DM32 have to actually measure that. So once I put it back up, you can see it here on the bottom right, I taped it in place so I could help take a picture, but when you're doing the test, you kind of hold it in place anyway. So you can see here I'm actually using my DucTester to do the reading. And I think somebody asked about what's the best way to use the static pressure probe, and you can see in the bottom right here, here's how I was kind of using this. It was off on the side, it was kind of being held, and it was just getting indirect pressures because it was kind of so far off from the flows. So that was what I was using. So here it is with the FlowFinder. Here I've modified it so it is just an open square. And this actually allowed me to test a lot more devices. I designed it for a microwave in the overhead units that do not have a microwave, still kind of a 3-inch gap that I just kind of tape off out a piece of cardboard to do that. Here is using the exhaust fan flow meter with it taped off. Again, not the best method. You're better off using the creating the little uniform cover that does all of it. So there's a variety of different methods. Again, here I was trying to show some options that were working or not working on how you could connect stuff and use devices. So I made these images and realized that I had to go around to my garage and make something quick to complete the process. So here I just want to show you some different connections, and clearly you can see that there's a variety of devices that just do not fit. So some people asked about what these are, the differences. So the pitot tube has an opening in the tip that allows you to measure the flow that actually moves into it. The static pressure probe just has openings on the side, and most pitot tubes actually do both. They actually have the static pressure probes on the side and the pitot tube. So if I wanted to measure flow, there's a variety of methods to do that. So the one you get is the one on the right with the Retrotec system, and that's what you saw in some of the pictures that I might have had. There is another method, again, and this is using a pitot tube, so I simplified the pitot tube so you understood that it was actually trying to measure the pressure that went into it, and that gets converted into a flow. And you can actually measure a kitchen exhaust hood. You can measure your dryer. You can measure anything that's flow. Some people use this to measure the flow that's in a ductwork, and there's a variety of methods of finding the best place to do it so you don't have turbulence and I get the max flow. Some people do a transverse where they're taking a variety of readings. My goal is to understand the concept about how this could work. Residential Energy Dynamics actually has a simple pitot tube airflow calculation. One of the versions that will be coming out with the DM32 probably this spring will be how to use you actually can connect a pitot tube and be able to do this automatically in the gauge. So these are kind of things that we think the smart gauge can do, and we're incorporating those and testing them out as we go. So this is one of our goals, that you'll be able to use a pitot tube directly on the device on the DM32. I usually, as I am now, kind of running short on time, and I will be in Chicago next week, and I have several people that I have appointments with about what are the best methods for testing ERVs and HRVs. And we'll do a webinar probably in March that's just on these itself. I will eliminate the exhaust fan sections or condense them into 2 minutes and focus on how to do these. And there is a wide range of results that I get. I hear more and more people explaining that most of them are now coming with pressure taps that actually allow this method to be measured. And I keep getting the question frequently about how do I test a ERV or HRV with a blower door, and I don't know the answer. So if somebody does, please chime in or give me the link on the Energy Circle or someplace, because somebody else figures out a way to test and do things, but I've not seen the results or seen the actual step A, B, and C. Most people are testing one and testing the intake, and then they test the exhaust separately to confirm that they're balanced. There are a variety of challenges depending on what your device looks like. Some of them have a fan cover that doesn't do well to actually connect you all the way around or get a good seal. So depending on what your device is, some people actually are going outside trying to do that. This came from Greg, I believe he's up in Canada. Greg maybe was today. So he actually has the ability to try to use the exhaust fan flow meter, the FlowFinder, because it does a great job of receiving air directly. So you can actually blow into this device, so the FlowFinder can actually read pressures directly. And I think he took his son's backpack or sleeping bag with Spider-Man on it to use as to seal the gap. And as you can see, one of the challenges is the issues with the lap siding or other challenges. So a lot of these things require creativity along with a device that's capable of reading your ERV or HRV. So it is on our hit list of things to conquer. If you're lucky, or it may be there and you weren't aware of it, there are more and more of these devices that are being provided with pressure ports that allow you to determine the pressures that are in your ERV or HRV. So Paul Raymer sent us this image of one of the units he had tested recently. So that makes life a whole lot easier to confirm that it is working correctly and balanced. One of the other ones that I frequently bring up that is out there is about how to measure the HVAC ventilation or the makeup air or additional air. I do not use the term fresh air because I don't know where it really comes from or what it's moving through to call it fresh. So replacement of ventilation air, that's a requirement in codes that actually have conditions where you do a blower door and you are equal to or below 5 air changes per hour, you must have installed ventilation system. Some municipalities accept only exhaust. Some say you must have a balance of exhaust and a supply system. So that conclusion can be depending on what program you're following. So there's a gray area there as to what you're required. The issue is how can I test this or determine the amount of flow that is happening or coming into the system. This is a requirement to be measured in California. So they want to know how much of this air. So sometimes they actually will do this not on the return but on the supply with a low-flow fan that's constantly adding air into the supply system. So all of these have their challenges. Some people in California use the exhaust fan flow meter up on the roof, measuring the amount of flow that's moving through the device to determine that. And I asked them, well, what do you do on a day that has any wind at all? That must be impacting your readings. So I think the industry is trying to do things, and we're all trying to catch up on how to measure them accurately. Yeah, I preach that there is no such thing. Jeff commented on, yeah, good call. There is no such thing as fresh air. When people talk about is the home too tight or why are we making home so tight, I ask them if they would feel comfortable, going over to a switch or a receptacle and putting their mouth over it and breathing. And they're like, oh, no way. So, but that's really what we do. We do breathe the air on the stuff that's in our walls. We just don't really want to see it or think about it. So I feel there's always strong sales tactics is to let people know that your goal is to give you better, healthier air and more comfort. That was my last line. We've been trying not to push the limit there, but our goal was to try and make sure we covered the simplicity or some of the challenges on what you can do with your how do you measure exhaust fan using exhaust fan flow meter with the Retrotec gauge. What are the best methods if you're going to use either gauge? Do you want to try and make sure you have both pressure ports being used? So you measure pressure and flow. There is a video that I actually did with, it's actually on our website or on our YouTube channel on how to actually use this device and set it up. And we kind of have a funny scenario that we're all in the bathroom doing this together. So if you really want to see how it actually comes into play or on the video that's up, this will probably be up in about 2 weeks. I made the slides today, try to make them more as individual slides. I will send these to Jay. Jay will create a PDF, and he will send you a link on how you can download those. We'll both be in Chicago next week, so we'll try and get it done by next Friday, so you can have the slide step-by-step on how to actually connect this to the exhaust fan flow meter, and all the other slides are included in here.